Hello everyone. Today we are going to learn one of the most powerful and interesting features in SQL, that is Recursive Common Table Expression, or simply Recursive CTE. If you have ever wanted to process hierarchical data like an organizational chart, calculate a running total, or generate a sequence of numbers, Recursive CTE are your go-to tool. Don't worry if this sounds complex. By the end of the session, it will feel much simpler. So, what is CTE? Let's start with the basics. A CTE, or Common Table Expression, is a temporary result set defined within the execution scope of a select, insert, update, or delete query. Think of it like a named subquery that you can reference as it were a table, but just for that query. Now, there are two types: non-recursive CTE, which don't refer to themselves. Then comes recursive CTE, which do. They are self-referential, and that's what we will focus on. What is recursive CTE? A recursive CTE allows a query to repeatedly refer to its own result. It's very useful for working with recursive or hierarchical data, like when each row leads to the next. So what are its use case? So its use case include finding employees under a manager, that is also known as organizational chart, building a category tree, that is parent-child structure, generating a list of dates or number dynamically. It's basically writing a loop in SQL. So now let's understand the structure of a recursive CTE. It has two parts. First is the anchor member. This is the base query that runs only once and sets the starting point. Then comes the recursive member. This part references the CTE itself and runs repeatedly, building on previous result. These two are combined using the union all or union. Most of the time we use union all because we want to keep duplicates and improve the performance. The recursion stops when the recursive query returns no more rows. So here what a typical recursive CTE looks like. With recursive CTE name, here it takes column list as a parameter, which is optional. As then comes the anchor member, then comes the union all, and then comes the recursive member. So let's break it down. With recursive starts the definition. The anchor is the initial rows. The recursive part uses the previous rows to get the next ones. The recursion continues until no new rows are generated. Now let's understand how recursion works step by step. First, the anchor query runs. This creates the initial result set. Then the recursive query runs using the result from the previous step. New rows are added to the result set. Step 2 repeats the recursive query, uses the new rows again. The loop continues until no more rows are returned. It's like stacking layer. You start from the base and then keep on adding one level at a time.